In this problem, we are going to determine whether the series is convergent or divergent. Our series is the sum n equals 1 to infinity of the term n to the third divided by n to the fourth plus 4. There are many tests you could use to successfully complete this problem, but right now we are going to use the integral test. That means we are going to consider the associated function f of x equals x to the third divided by x to the fourth plus 4. We are going to observe three things. The first is that f is continuous for all x values for which the denominator is not equal to 0. Therefore, it's continuous unless x to the fourth plus 4 equals 0, but this has no real solution. So we can conclude that f is continuous on the interval negative infinity to positive infinity. The second thing we need to decide is whether f is positive. So for all x values greater than 0, we know that all three terms, x to the third, x to the fourth, and 4, are positive. So that means that f of x is positive. So our function is positive on the interval 0 to infinity. The third thing we need to determine is whether f is decreasing. In order to determine whether f is decreasing, we will use our knowledge from Calc 1 and look at the derivative. So f prime of x, I'm using the quotient rule, is x to the fourth plus 4 times 3x squared minus x to the third times 4x to the third divided by x to the fourth plus 4. A little bit of algebra will tell us that this is equal to negative x squared times x to the fourth minus 12 divided by x to the fourth plus 4. Now, f prime is equal to 0 if the top of this fraction is equal to 0. So if x equals 0 or x to the fourth minus 12 equals 0, well, this means x is positive or negative 12 to the 1/4 power. Or in other words, positive or negative 1.86 approximately. Let's think about what happens if x is greater than 1.86. Well, then we know x to the fourth minus 12 is greater than 0. So x squared times x to the fourth minus 12 divided by x to the fourth plus 4 squared is greater than 0. We know this because x squared and the denominator x to the fourth plus 4 squared, being squares of real numbers, are both positive. And so that means that negative x squared, x to the fourth minus 12, divided by x to the fourth plus 4 squared is less than 0 because I've multiplied by negative 1. Well, this is the expression for our derivative. So our derivative is negative. That means that the answer to our question, is f decreasing, is yes, as long as x is greater than 12 to the 1/4 power. Okay. Or in other words, f is decreasing on the interval 2 to infinity. I'm just rounding the 1.86 up to the whole number 2. Now, the integral test as it's stated in the textbook does call for f to be decreasing on the interval from 1 to infinity. However, this is unimportant because if we know the series converges, if the sum starts at 2, then we can just add one more term and know that the series converges with the sum starting at 1. Now what we've done so far is we've shown that the function f satisfies the hypotheses that are required for the integral test. The integral test says that our series converges if and only if the improper integral from 1 to infinity of the function x to the third over x to the fourth plus 4 dx converges. So we will now look at this integral. We know by definition this is the limit as t approaches infinity of the integral from 1 to t x to the third divided by x to the fourth plus 4 dx. And I can do a u substitution. I'll choose u to be the denominator, x to the fourth plus 4. Then du is 4x to the third dx, or in other words, 1/4 du is equal to x to the third dx. I will also change my bounds. So our lower bound is x equals 1. Well, that means that u is equal to 1 to the fourth plus 4, which is 5. And our upper bound is x equals t, which means u is equal to t to the fourth plus 4. So we can rewrite our limit as the limit as t approaches infinity of the integral from 5 to t to the fourth plus 4 of 1 over u times 1/4 du. Now finding the antiderivative, we have 1/4 times the natural log of the absolute value of u, evaluated from 5 to t to the fourth plus 4. So I have the limit as t approaches infinity of 1/4 natural log of t to the fourth plus 4 minus 1/4 natural log of 5. Now, as t approaches infinity, t to the fourth plus 4 approaches infinity, which means natural log of t to the fourth plus 4 approaches infinity. So this limit is infinite. Our conclusion for our improper integral is that this integral diverges. Our overall conclusion for the problem is that by the integral test, this series n to the third divided by n to the fourth plus 4 diverges.